Okay, the last part of this lesson has to deal with vertical shifts. Those would be the shifting of the graphs up or down on the XY plane. Things you need to know. The first thing is that the capital A, as we talked about earlier, represents amplitude. So amplitude stretches or shrinks your graph based on the magnifier that's put in front of it. So if there isn't a number there, there's really a 1, and that's just a basic sine or cosine graph. Then there's a B and a C, but they're coming next week. I don't even want to go there with you today. I just want you to know that there is a B and C so that it doesn't look strange that at the end there's a capital D. And the D stands for the vertical change or the vertical shift. Okay, so this is going to be the vertical shift. And this vertical shift is a constant. And the constant tells you how far up or how far down that the entire graph is going to move. Okay, so keep in mind that if it's a positive, that is a shift up, just like in our parent functions. And if it's a negative, it's a shift down. Okay, so what we need to do is we need to basically graph whatever our graph is with the amplitude, and then go ahead and do a shift as a second graph on the axis. So let's take a look at what this would look like. So if I have y equals 3 sine theta plus 2, what this says is I've got a sine function where my normal is 0, 1, 0, -1, 0. Those are my normal sine function values for 0 degrees, 90 degrees, 180 degrees, 270, and 360. So these would be the ones that I would graph normal. But I'm not going to graph these. What I will graph is the amplitude, which is a multiplier of 3. So now, as soon as I have the sine function times 3, I'm now at 3 times 0 is 0. This is 3. This is 0. This is -3. And this is 0. And this is what I would be plotting first. So on my graph over here, and I can do this pretty fast. 1, 2, 3, 1, 2, 3. Line in the middle. Maybe one more line here. 1, 2, 3. -1, -2, -3. 90, 180, 270, 360. There's our setup for our basic 3 sine theta. All right, so this is the sine function times 3. That's 3 sine theta. Those are the values that I would be plotting. So 0 at 90, I'd go up to 3. 0, 270, go down to -3, back to 0. This is my stretch with an amplitude of 3, sideways S. What this value says, this value D, tells me that I need to shift all my points up to. Shift all points up to. Uh-oh, looks like we need to go a little higher because our highest point is at 3, which means I need to go all the way up here to 5, but that's cool. And I'm going to go orange so I can show you that this shift is very easy. If you're at 0, go up 2. 3, go up 2. At 0, go up 2. At -3, go up 2. Oh, look at that. Let's fix that. There we go. And then at 0, go up 2. And when I go to connect them, I'm going to have the same exact graph. It's just going to be shifted up. And this is my final graph. This is y equals 3 sine theta plus 2. All it did was shift each point up 2 units from my original 3 sine theta graph. Okay, so what you want to do is you want to make sure that you're graphing the amplitude with your regular function. Like all this is going to be your first graph. Okay, I call that your base graph because that's the one that you're going to use. And then this part tells you what to do with it, shift up. All right, let's take a look at another one. Second one, let's do y equals, let's throw a reflection in there. We'll do a small sine theta minus 4. Ooh, that's a big one. Let's see what we got going on here. So the first thing we want to do is take a look at the fact that we have a reflection in the x-axis, which is going to make us switch positions from top to bottom. We've got an amplitude of 1/2. Amplitude of 1/2 means that this is going to shrink to half its size. Sine means we're still going to have our basic sign. So 0, 1, 0, -1, 0. But we're going to make sure that we do half of those values and a negative for our base graph. So -1/2 times 0 is 0. -1/2 times 1 is -1/2. 0. A negative times negative is +1/2, and then 0. So this is going to be our base graph of y equals -1/2 sine theta. That's the amplitude shrink and also the reflection in the x-axis. We have to do that first. Then this guy right here says that we have to shift everything down 4 units. So we should be planning that a little bit so we don't get caught. Now, it's basic to go from 1 to -1 or from -1/2 to half. But moving down 4 means that I need to be, the lowest point is at -1/2, so I need to go down to like -5. And then the highest point is at 1/2. So I think I'll be good. So this is going to be bottom. Here's 0, -1, -2, -3, -4, -5. Again, because I'm shifting down 4 units, I need to make sure that I have enough space down here. My highest point is only going to be at +1/2 for my purple one. Oh, don't forget your 90 degrees, 180, 270, 360. All right. So we're going to plot our base graph first. So 0. Then at 90, we have to go to -1/2. That's here. Then 0. Then +1/2. Then 0. So this is what our base graph will look like. Again, it's shrunk because of the amplitude. It's only half as tall as it normally would be. Then we've got to take this guy, and we literally have to go down 4 units. So 0 is going to go down to -4. 90 is going to go down to -4.5. 180 is going to go to -4. 270 is going to go down to 3.5. This is a half. This is 1, 2, 3, 4. And this one's going to go down to -4. So this is our sine function. It's a sideways S. And we know it's a negative because it starts at 0 and moves down first. So it's got a negative or a reflection in the x-axis. And it's also shifted down 4 because from our first point, it's instead of it being at 0, it's at negative 4. So that's what our shift is. So this one is y equals negative 1/2 sine theta minus 4. Again, you need to get your regular sign, multiply out your base function, which is any kind of multipliers you have, and do that first. Then do your shift second. So this is your final answer, is in orange. What we're going to do is we're going to take a look at one more, except this time I want to do a cosine graph just so that you can see how the vertical shift works. So if I have y equals, and I'll do a easy one. I'll do like cosine theta minus 3. So basic cosine theta minus 3. We can't forget our basic cosine. So the first thing you need to know is that the amplitude is 1. So even though there's no number there, that amplitude is always a multiplier in front, so the amplitude is 1. That means that we're going to go up 1, down 1. That's it. Basic cosine means that we're using the x values on the unit circle. So starting with 1, 0, negative 1, 0, and 1. This represents 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. So these are the values for basic cosine. Now, there's no other like multiplier there, meaning I'm multiplying by 1. I'm going to get back what I started. There's no reflection in the x-axis, so I don't have to flip anything over. I just have to plot this one and then shift this down 3. So what's good is the lowest point, if I'm shifting down, the lowest point from our original is negative 1. So down 3, I would just need down to negative 4. So let's see if this will fit. If this is negative 4, negative 3, negative 2, negative 1, 0, 1, might work. Okay. Let's go 90, 180, 270, 360, and here's our original. This is our base function. We only need to graph this one. So starting at 1, 0, negative 1, 0, and 1. Basic cosine curve. Make a waterfall and then under, waterfall and under, make a nice U shape. And then we're going to shift it down. So when we shift down 3, we start here, 1, 2, 3. This one, 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 1, 2, 3. And then redraw right here. And this is y equals cosine theta minus 3. All right, I'm going to give you a couple to try for your assignment and contact us if you have questions.